Hey everyone, and welcome back to another Prep to Perfection Grade 12 Maths class. Just a quick reminder, if you boost your marks, you stand a chance to win 5,000 Rand. How amazing. Simply click the link down below to enter the competition. I'll now hand you over to your tutor, Camilla.
As part of trigonometry, we'll be looking at compound angle identities. A compound angle is an angle formed by adding or subtracting two angles. Remember, capital letter represents an angle while a small letter represents a side. So here are our key identities. We'll take a deeper look into them, however, just an overview. Sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. Cos A plus B is cos A cos B minus sin A sin B. And then cos A minus B is cos A cos B plus sin A sin B. Compound angle formulas. We are now going to look at the derivation for cos A minus B. Using the distant formula and the cosine rule, we can derive the following identity for compound angles. Cos A minus B equals cos A cos B plus sin A sin B. Consider the unit circle r equals 1 below. The 2 points L is AB and K, XY are shown on the circle. We can express the coordinates of L and K in terms of angles A and B. Point L equals cos B sin B. Point K equals cos A sin A. Using the distance formula, KL to the power of 2 equals open brackets cos A minus cos B, close brackets to the power of 2, plus sin A minus sin B to the power of 2. We get an answer of 2 minus 2 open brackets cos A times cos B plus sin A times sin B. Now we determine KL to the power of 2 using the cosine rule of the triangle KOL, where KO is 1, LO is 1. We sub that in, we get 1 to the power of 2 plus 1 to the power of 2 minus 2 times 1 cos A minus B. From here, we then get the answer of 2 minus 2 times cos A B. Therefore, equating the two expressions for KL to the power of 2, we have 2 minus 2 times cos A B minus B equals 2 minus 2 cos A times cos B plus sin A times sin B. This will then give us cos A minus cos B equals cos A times cos B plus sin A times sin B. Derive an expression cos open brackets A plus B in terms of trigonometric ratio of A and B. Use the compound angle formula for cos open brackets A minus B that we did previously. Cos open brackets A plus B equals cos open brackets A minus open brackets negative B close brackets. Therefore, cos open brackets A minus B equals cos A cos negative B plus sin A sin negative B. Cos A plus B equals cos A cos B minus sin A sin B. Derive the expanded formula for sin open brackets A minus B and sin A plus B in terms of the trigonometric ratio of A and B. For step 1, we can write sin open brackets A plus B close bracket in terms of the cosine function. So this will give us sin A equals cos open brackets 90 degrees minus 1, which will give us cos double open brackets 90 degrees minus A plus B. Step 2 is our compound angles. To derive the formula for sine, open brackets, a plus b, close brackets, we use the compound formula for sine, open brackets, a minus b, close brackets, and manipulate the sign of b. Cos, open brackets, a plus b equals cos a times cos b minus sine a times sine b. This will give us cos double open brackets 90 degrees minus a close brackets plus b close brackets. This will equal cos open brackets 90 degrees minus a times cos b minus sine open brackets 90 degrees minus a times sine b. Our second compound formula is sine open brackets a minus b, which equals sine a cos b minus cos a sine b. Sine a minus b equals sine a times cos open brackets minus b, negative b, minus cos a times sine negative b. This will give us sine open brackets a plus b equals sine a times cos b plus cos a sine b. Though that was our final answer, we can also write the final answer for sine open brackets a minus b, which is sine a minus b is equal to sine a times cos b minus cos a sine b. Now we're going to look at a couple of practice questions. So, if cos A is equal to 3 over 5 and sine B is equal to 4 over 5, where both A and B are in the first quadrant, find cos open brackets A minus B. We know that cos open brackets A minus B is one of our identities, so we can say cos open brackets A minus B is equal to cos A times cos B plus sine A times sine B. We then need to work out what A and B is for each of these. So we know that cos A is equal to 3 over 5 because it's given to us. Then we know sine B is equal to 4 over 5. It is also given to us. So from these values, we know that 3 will be our adjacent, 5 will be our hypotenuse, and 4 will be our opposite. So we can work out cos B equals 3 over 5, cos A 3 over 5, sine A equals 4 over 5. We plug these values in. This will give us 1. If sine A equals 5 over 13 and sine B equals 12 over 13, with both A and B are in the first quadrant, calculate sine open brackets A plus B. We can do this as we know the compound angle. So it equals sine A times cos B plus cos A times sine B. Now we are given sine A, which equals 5 over 13, and sine B, which equals 12 over 13 in the question. Now we need to find cos B and cos A. We can work that out by saying cos A is equal to root square of 1 minus sine squared A. This gives us 12 over 13. Cos B equals root squared of 1 minus sine squared B, which gives us 5 over 13. We plug these values into our compound angle formula, and that gives us 1. Therefore, sine open brackets A plus B equals 1, meaning A plus B is 90 degrees. Proven identities prove that cos A minus B minus cos A plus B equals 2 times sine A times sine B. We're going to look at the left-hand side first. Cos open brackets A minus B minus cos open brackets A plus B. Here we just use our compound angles to get cos A times cos B plus sine A times sine B. And then cos A times cos B minus sine A times sine B. We simplify them and we get 2 times sine A times sine B. This will equal the right hand side, and therefore cos open brackets A minus B close brackets minus cos open brackets A plus B equals 2 times sine A times sine B.
Alright everyone, that's it for today. But don't forget to keep practicing so that you stand a chance to win 5,000 Rand. Click the link down below to enter the competition and we'll see you in the next class.